Hello, this is Alan again on another of my ECL videos, this time on the built-in denormalize function. I'm showing this after normalize because it's the inverse to denormalize. So with normalize, I'll just remind you, we have a hierarchical data set, a data set with child data inside it. Here an example of address with residence at that address, and we want to split out the child data set from the hierarchy, so we end up with the outputs just being the flat data set with perhaps propagation of internal IDs or some other information from a parent. So that was in the previous video, and now denormalize is the inverse. So we now have two flat inputs data sets joinable by some condition. In the example here, I've just an internal ID that makes these two tables joinable, and the output is the hierarchical data set that we saw in the normalized case, as input for the normalized case. So I think I better show, it's complex enough to actually warrant a PowerPoint presentation before we dive into the ECL. So here are input, we've got two inputs, input for parent, input from child coming in here, and the first, there's two variants of denormalize, and the variant I'll be showing here, the input to denormalize on the left hand side has to be the same as the output format. So invariably your input for parent isn't actually in the output format of a denormalize, so you have to run it through a project to get it into the output format. So we're doing that here, and we default the child data sets to empty data sets. So we're now all ready to run denormalize. So the parents, the target data set for parent information goes in on the left, and the inputs for child goes in on the right. Again, it's denormalized as joined on ID here. Now denormalize, when it does its stuff inside its transform, obviously it removes duplicate information. You don't need two ID1s, so it can remove that, and effectively that's its output. Now the output is now fed into the, if there's a further child entry for this parent record, which there is in our case, then this particular result gets fed back in as input to the left hand side, and the next child record is selected with the same ID. So this left side is now the input, it does its processing, and we now get a new output result hierarchical data set, which is fed in as input again because there's still further child entries to run. And here it does, processing the last of the ID1 entries, and now there are no further child records for this parent record, so that will now become the output, and the next parent record will be brought in on the left hand side for as the next input. So we can see that. So the outputs, so item 1 is now completely generated, and we're now processing item 2, joined again by ID, and the same process as happens this time, but because there's no further child records for the parent record, that will immediately get moved to the output record there. So I think that's enough of the, that's what's actually going on. So I think we can look at the ECL that it would implement something like this. So here we are. Our inputs are firstly the child data set. Again, we've got to have an ID here because it's got to be joinable, and we've got the address, which we've decided is going to be the parent record, and the output is obviously going to be the address with the ID. And the child record is going to be a data set of the child record formats, but obviously we don't want the ID of a child record in there, so we can remove that, and I've just put a tracing count in to just show you the behaviour of counter in this situation. So that's going to be, and that will be, the child record will be called residence. These two data sets here just populate the parent, input parent and child data sets for us. And this is the preparatory transform that massages the parent record into the output record format here. And then we're ready to do the denormalize proper. So our left hand side parent record is the massaged input, and we can just pass the child information in directly on the right hand side. Again, it's joinable very much like join. In fact, the documentation says that denormalize is just a specialized form of join. And add residence and the usual parameters left, right, and as I said, count as an optional parameter, but I'm just putting it in to just show the behaviour counter. And this is the transform. Well, our output record and input record type on the left hand side have to be the same. This is obviously the type of the child, and this is just our tracing count. So the parent record can be the ID, address is obviously from the parent record. Now residence is just whatever was in residence before. Remember, with the project we start off with an empty data set, so the first time in L residence will be an empty data set, and we're concatenating a new record onto the child data set. So we're making that first name, last name, tracing out count, and that's its record type there, our out residence. This gets generated, but because there's still further child records for ID1, this will be presented as the input again on the second iteration, and this time residence will have one record in it, and again we're going to be appending the second child record associates with 1 to this. I could use ampersand. You can concatenate with plus. The only difference there is a plus is I don't really need the output order of the child records. I don't really care. Whereas ampersand says, look, I want this at the end, so I'm appending to the existing data set. So let's just run this and see what we get. Oh, I'll show you the ECL, which is actually easier to see in the when it comes up. And there we go. We've actually got the input from normalize. I've actually added a fifth element that has no child records with it at all. That just gets passed to the output here. There's a few subtleties involved. Oh, by the way, count, as you can see, gets incremented every time for the child record, but when the new parent record is presented, the counter gets reset back to 1. Okay. Now, there's a few subtleties here with transform, and really I recommend that you go away with code like this and just play with small examples, because it's not completely obvious what's going on. Right, so let's say we skip, as any transform we can have a skip in there. Let's say we're skipping all records whose first name's greater than 3, and let's see what happens here. Seems to be taking a particularly long time today. I should have pre-done these, saved a bit of time. Result 1, 3 rows. Okay, interestingly, well, obviously the filter's been applied, but where the filter has got rid of every parent, in other words, there's no child that satisfies the criteria. So no children are being generated for item 2 and 4, and we can see that because item 2, both the first names are longer than 3 characters, and here in item 4 the first name's longer than 3 characters, so they don't get generated at all. But where you've got absolutely no children records at all, it actually is generated. So, you know, where you filter out everything in the skip, you still get a record, but if you've got no children whatsoever that actually match on the join, then because the default is left outer, you still get that parent record. So I thought I'd better mention that to you. There's another bit of a got you with this, in that I'll just show you the reference manual here. So because denormalize is basically a specialized form of join, the various types of join, left outer, right outer, whatever, are also available for use in denormalize and act just as they do with join. Right, so that's from the reference manual, latest version. But here I'll just show you that that's a left outer. So if I do inner here, you can see, oh, actually let's just show you that. So you have to specify inner. Inner's the default, supposedly, and it's definitely the default for join, but it's not the default for denormalize. Ah, there we go. We can actually see from the other output. So there we've excluded item 5 because we've explicitly said inner join. So the denormalize by default is a left outer. Now if we just change that quickly to a join, you would expect, with the same default that we gave to denormalize initially, you'd expect left outer. But you don't, you get an inner join. So you only get the same results as denormalize if you actually specify left outer, and then you will get item 5. So there you are, item 5, it's been specified. But with denormalize, the default, if it was the same as the documentation, that should be an inner join. But in fact, as we saw earlier, just reproducing it here again now, perhaps I should have put this in the gotchas. I think I'll write another video specifically. There we go. So the default is different for denormalize on the join type from join, which for me does not tie up with what's said in the reference manual. As I said, I think I'll do a gotcha playlist, because I've got a second playlist on gotchas, and I think this warrants one of those. But really the moral of the story is, before you use anything, really play around to it and get out the subtleties before you can be comfortable of using it. Anyway, all the best. See you in the next video. Cheers.